Hi, this is Carol Hobbs again. Instead of doing something for the parents, I'm going to kind of do something that would help high school, definitely college students, because I teach college algebra at a local university here. Now, one of the problems I'm going to work with, at this point we're dealing with radical equations. And how do you solve radical equations? Well, I'll show you how. This is one of our examples. Instructions are simply to solve, and we are solving the square root of 2x plus 3 minus the square root of x plus 2, and that equals 2. That equals 2. Now, the idea is that this leftmost radical should remain on the left-hand side of the equal sign. The square root of x plus 2 we're going to transfer to the other side, and we do that by doing the opposite of how it's connected to the first radical. So we add the square root of x plus 2 to both sides. So now we have the square root of 2x plus 3, and that's going to equal the square root of x plus 2 plus 2. Now, one way of eliminating the radical symbol is to take the square. Whatever the index is, that little superscript number that goes in that little spot there, that is what you would use. If it's a 3, you would cube it to the 3rd power. If it's a 4, you would quartic it, okay, to the 4th power. If it's a 5, it would take it to the 5th power. So in this case, we're going to, because it's a square root and square means 2, we're going to take this to the 2nd power. And you know what you do to one side of the equal sign, you must do to the other. My red is not very red, is it? Okay, as I said, the square will eliminate the radical symbol. So now we have 2x plus 3, and that's going to equal, now on this side I must FOIL. Anything quantity to the 2nd power means the square root of x plus 2 times the square root of x plus 2 plus 2. So this I will FOIL. Square root of x plus 2 times the square root of x plus 2. It's 2 of them, and since it's 2 and you're multiplying, you eliminate the radical, because that is the square root of x plus 2 squared. So then we will have just x plus 2. Our outer is the square root of x plus 2 times 2, so that gives us 2 times the square root of x plus 2. Our inner is the same 2 times the square root of x plus 2. And our last is 2 times 2, so that is plus 4. Now notice we can combine like terms here. So now we have 2x plus 3 equals x plus 6 plus, now we can combine these like terms because the radicals are the same. So 2 square root of x plus 2 plus 2 times the square root of x plus 2 is 4 times the square root of x plus 2. Now I've got to get a bigger board. But now one of the things that we have to do is we're going to subtract x from both sides, and we're going to subtract 6 from both sides. We want to isolate this radical by itself again. So subtracting x and subtracting 6 we now have x minus 3 equals 4 times the square root of, so x minus 3 equals 4 times the square root of x plus 2. I'm going to come up here and erase some things. I'm sorry I can't leave it all up at the same time. And rewrite what I have there. X minus 3 equals 4 times the square root of x plus 2. And now I've got to take the square root on both sides again because I still have a radical here that I must eliminate. So I square both sides. Square both sides. Now this side says I must FOIL again because I have x minus 3 times x minus 3. And this side, we square this. So 4 squared is 16. And remember, the square eliminates the radical symbol. So it's going to be 16 times x plus 2. 16 times x plus 2. Now I'm going to FOIL this left-hand side. First times first is x squared. Outer times outer is negative 3x. Inner times inner is negative 3x. And last times last, negative 3 times negative 3 is our last times last. So that gives us a positive 9. Negative times negative is positive. So that, now I'm going to distribute this. I'm going to distribute the 16 through both terms inside the parentheses. 16 times x is 16x. 16 times 2 is positive 32. Okay, I'm going to combine like terms. The negative 3x are alike, so they are like terms. I'm going to combine them. Combine means to add or subtract, whichever is relevant. So that's x squared minus 6x plus 9, and that's going to equal 16x plus 32. Now I'm going to subtract because I need this in quadratic form, and quadratic form is ax squared plus bx plus c equals 0. So that's the form that I need this in. And my light it's not that light, it's the light behind. So that is actually ax squared plus bx plus c. I think you got a glimpse of it there. So now I'm going to subtract 16x from both sides, and I'm going to subtract 32 from both sides. So that would leave me with x squared minus 22x. Negative 6 plus negative 16 is negative 22. Positive 9 minus 32 is negative 24. And that's going to equal 0 because both of these terms drop out. Now you see I have a trinomial that is factorable. 23 is a prime number. Excuse me guys, I hate to do this, but I'm going to have to eliminate some of this up top. So x squared minus 22x minus 23 equals 0. Okay, now we're going to factor this. I set up I always start by setting up two sets of parentheses. I factor my first term, x squared. That becomes x and x. Then I look at my last term. My last term is 23, which is a prime number, so its only factors are 1 and 23. Now, to complete this factoring, I look at my middle term. That sign tells me that I need a negative 22. Well, I have a 23 here and a 1 here. That says the 23 should be negative and the 1 positive. Negative 3 plus 1 gives us negative 22. I've checked. So I'm really good. 1 times negative 23 is negative 23, and x times x is x squared. So now we're going to use what they call the zero product property. That property says you take both of these and set them equal to 0 individually. So we have x plus 1 equals 0 and x minus 23 equals 0. Those are our two factors. Now, one of the things to note, that highest exponent does give you some information. It tells you how many possible solutions you should have. So if that was 3, we're looking for 3 solutions, 4 solutions, and so on. So now I'm going to solve. Here we just have to change our signs. Subtract 1, x equals negative 1, and then we're going to add 23. So x equals 23. These are our two possible solutions. I would like to add, it would be important for you to check both of these solutions in the original problem. Never the one you changed, never the one you altered, only the original problem, to ensure that both of them, or only one, is the proper answer. And in this case, I think 23 is the only real answer. Thank you. God bless.